How's it going? This is Josh. Today we're going to be working on absolute value inequalities. Now I'm hoping you've watched some of my other videos so you kind of have an idea as to what absolute value means. I'm hoping you understand what inequalities are. So now we're just kind of putting those two things together and working through some equations. This is one of those topics that I want to get through kind of quick because I feel like once you see it, I think you'll be able to catch on. So I just did 3 problems here. I'm going to go at a moderate pace through them, but I'm going to talk you through them. And this is one of those situations where I do encourage you, if you're kind of seeing what I'm doing on this one and you want to try it on the next 2, I say go for it. Pause the video, try them on your own. It's so much better if you try these and then fail. And then, I know that doesn't sound that great, but it really is. There's all this study now, all these researchers that are saying that like by learning through failing, you're really actually creating these massive breakthroughs. In fact, one of the quotes is like, you know, every time you break down, you're actually going through a breakthrough. Not to get philosophical on this, let's get back to the math, okay? Anyways, let's go through this guy here. I'm going to rewrite them. X minus 4 less than 3, absolute value, okay? And we have the fact that it's less than 3. Okay, well, anytime you're working on these absolute value problems, you're always going to have 2 different versions of the problem. And as we solve them, I'm going to kind of talk through that as well. So you're going to have your positive version and your negative version of this problem. And so what I mean by that is we're going to rewrite it, but we're going to keep that inequality sign for now. X minus 4, the positive version is just the same thing. X minus 4 is less than 3. The negative version is going to be X minus 4. This is one of the big changes, okay? Instead of, when it's an equal sign, it doesn't matter. But when it's an inequality, on the positive side, you just leave it alone. On the negative side, you change the direction of the inequality and make the value the opposite, okay? So I don't want to say go negative because if this is a negative 3, now you're going to make it a positive 3. But because it's a positive 3, we're going to make it into a negative 3. And now we solve them as if it was just an equation, an algebraic equation. And so let's see here, we have x, we got to isolate the variable, just like everything else I always teach. Variables on one side, numbers on the other. Add 4 to both sides, add 4 to both sides, here we go. X is less than 3 plus 4 is 7. So far so good. I'm sorry, x is less than 7. And then on this side, add 4, x is greater than, let's see here, negative 3 plus 4 is 1. Greater than 1, okay? And now I didn't plan on this, but let's graph these as well. We already have the information, let's graph them and then see if our values or our answers work. Okay, so when you graph these, you're just using an x-axis, right? We're dealing with x side to side on the number line. I always encourage students to put in a 0 just because it's kind of like a nice placeholder. And I personally, when I'm scoring these for a student, I'm just looking to see if you're writing these numbers in the right place somewhere on the number line. I'm not going to count 1, 2, 3, 4 and see if they're exactly spaced. In fact, I usually just draw it as like, I don't know, let's say that's 1 and then 7 is out here. No, they're not 7 units apart. You might have a teacher that wants you to do it so specific where you're using like, the blue graph paper and then you're like counting all of the lines. And that works, right? For the first 6 to 10 values, okay? But then once you get out here, like what if this was like x is greater than 96? Are you really gonna go 96 spaces? Come on. So if that's the case, then I just tell students, you know what? Put them on the right side of the 0 so we know if it's a positive number or a negative number. And then from there, this is good enough. But make those bubbles, okay? Make them big enough so that when you solve these things, you're able to really clearly define what's going on. So in this situation, we have x is greater than 1, okay? It's not equal to 1, so we can't shade the bubble. If you're not sure on shading the bubble, check out my other video on inequalities. And x is less than 7, so x is less than 7. So it looks like these two arrows are going to kind of run into each other. Now, could you leave it like this? Awesome, looks great. Could you also just kind of shade this whole box thing in here? You know, I have students that just love to color, and they love to just color in that whole thing. Yes, you can, all right? Either answer is gonna work. Just be careful when you start coloring this thing in. Don't get color crazy and color in the bubbles, okay? Because then your teacher might take off points because they're gonna say that you shaded the bubble. If you shade the bubble, that means that one of these numbers is actually a solution as well. So now that we have our answer, I guess we have our answer here, but we also have our answer graphically as well. Let's plug in some values and see if it actually works. So a number greater than 1 but less than 7, 2, right? And if 1 works, all of them should work, but we'll pick a couple. So let's pick the number 2. 2 minus 4 is negative 2. Absolute value of negative 2 is 2. Is 2 less than 3? Yes. Let's try 6, because it's close to the other side. 6 minus 4 is 2. Absolute value of 2 is 2. Is 2 less than 3? Yes. Okay, and now let's pick a number that wouldn't work or that's outside the parameters here, like 0. 0 minus 4 is negative 4. Absolute value of negative 4 is 4. Is 4 less than 3? No. And so that's how we can justify or prove mathematically or algebraically why this is correct, or why these values in between the two numbers here are all solutions to this set. Okay? So now that I've gone through this one, like I said, feel free, pause the video, try these ones. Now these ones have a little bit extra stuff in them, so if you want to watch this guy, maybe then you should definitely be able to handle this guy if you watch me do this one, okay? But sometimes I say go for it, right? If you think you're on the right path, I would not want to stop you. I would rather you try it, make a couple errors, because then when I go through it, you'll say, oh, Josh, now I see what I did wrong. No worries, you're all set. Let me write this a little bit bigger. 2x plus 1 minus 3 greater than or equal to 6. All right? Now, when you have this extra little part here, you got to get rid of it. You got to get it just clear off the slate, move it out of the way. You can only work with the absolute value on one side and your numbers and things on the other. So first thing we should do is just plus 3 to both sides to get rid of that guy. Okay, I'm going to rewrite it. 2x plus 1 greater than or equal to 9. Okay? So that's our first step. Anytime you have this extra part, just get rid of it. Move it to the other side. Now we can work with this guy, and now we can set up our positive and negative versions of the problem. So I have 2x plus 1 is greater than or equal to 9, and 2x plus 1 is, don't forget, negative version. So we need to flip the inequality here and make it go the other direction. We keep the equal sign because that's part of it. And we're going to make that a negative 9. So just remember, these two guys are going to trip you up. Don't let it happen. Let's go through this guy, isolate the variable. So minus 1, minus 1. So we have 2x is greater than or equal to 8. Divide by 2, isolate the variable, down to 1 unit. X is greater than or equal to 8. We read our fractions down. 8 divided by 2 is 4. On this side, minus 1, minus 1. We get 2x is less than or equal to negative 10. Divide by 2, divide by 2. X is less than or equal to negative 10 divided by 2 is negative 5. I'm going to graph this one kind of out of space. I know there's a glare up here sometimes. So let me graph this guy. This ain't going to be pretty. Let me erase this. I try not to do that just because I kind of like having everything in one place, but I guess that's just not going to work out today. So set up our 0. If you want to put in your minus and plus, I don't know. It's helpful. I like it. Let's read it from the x. X is greater than or equal to 4, so I'll put my positive 4 over here. It's greater than 4, but it's also equal to 4. So because it's equal to 4, I do shade the bubble. And then I got x is less than or equal to negative 5. Before you get into this part, just look at the number, right? It's a negative 5. Then tell yourself x is less than or equal to negative 5. I truly believe that by saying it out loud, you do help yourself in the explanation. It's less than negative 5. It's also equal to negative 5. Okay? And then from there, now we have our parameters. We know that it has to be greater than 4, less than negative 5. And yes, you could prove, you could put these numbers, you could pick numbers on either side to justify your answer, to prove it algebraically, and you should be all set from there. Now that I've shown you this guy, I'm hoping you would be able to do this one. But let's do it together if you want to follow along. I do feel it's important that you guys try these on your own, right? This is not edutainment. This is not just, hey, I'm just going to watch this and learn it real quick. Oh man, look how awful that blue erases. I'm gonna really try to do these problems. I'm hoping that's why you're watching these videos, is so that you can really take a part in what's happening here and you're not just watching. Let's see here, -1, that's greater than or equal to 10. Okay. Again, this guy has got to go. So let's add 1, add 1. Okay, and then we got 3x plus 2 is greater than or equal to 11. Okay. Now we got to set it up. Our positive problem and our negative problem. We have the positive is always just a rewrite of the same thing. So 3x plus 2 is greater than or equal to 11. This one over here is 3x plus 2 is less than or equal to negative 11. And now let's work through these guys and see what we get. I'm going to stay away from that blue just because it's kind of jacked. Let's see here. -2. It doesn't erase very well on my board is what I'm trying to say. 3x is greater than or equal to 9. Okay, and I know some of this I'm going kind of fast, but come on, if you're in absolute value inequalities, you should be able to handle the speed at which I'm working on this stuff down here. Isolate the variable down to single unit, divide by 3, read our fractions down. X is greater than or equal to 9 divided by 3 is 3. Let's make that a little neater. Okay. And over here, let's see here, -2, -2. Negative 11 minus 2 is negative 13. Oh, we get some crazy fraction. That's okay. We get 3x is less than or equal to negative 13. We can divide both sides by 3. X is less than or equal to negative 13 thirds. Okay. Now the nice thing about this is you don't really, this is one of those situations where you don't really need to condense that into another fraction. If you want to change it into a mixed number, then you can. I personally don't care. When I teach this stuff in a classroom, I feel like it's more important that you understand how to get here after doing all this crazy math. I'd rather you just understand how to get here, because, you know, if it comes down to changing it into a mixed number, then okay, well, but that's not a big deal, right? This is the big deal, understanding all these rules and crazy stuff. Let's set up our line, set it to 0. X is greater than or equal to 3. Okay. Let's see here. I'll just put my 3 here. And it's greater than or equal to 3. So it's equal to it or greater. And then I know that negative 13 thirds is back here. It's a negative. So it really doesn't matter where I put it. And again, that's another reason why do I need to convert this into a mixed number? Because if I know it's on the negative side, all I really encourage my students to do is just put it in the right place, which is on the negative side of the x-axis, or the, you know, the number line, and then just graph it from there, because I'm not measuring like how far this is away, right? I talked about that in the beginning. It's more about where are you placing these bubbles? Are you shading them? Are you doing the algebra work correctly? Those are my main concerns with stuff like this, because this is kind of like a building thing, right? There's more to this, but these are the basics, and we got to make sure we get them down. Less than or equal to, it's equal to and less than. All right, and we're all set. Okay, so if you really wanted to make, figure out that number, yes, you could put it in a calculator. Yes, you could make a mixed number, but at this point, it really isn't necessary. Okay, now the one thing that I didn't really put into this was when you have this. Let's do 4 minus 2x, absolute value is greater than, we'll say 10. Okay, we're going to keep the numbers nice and clean. Okay, let's see here. We have our plus version and our minus version. So let's rewrite it. So we have 4 minus 2x is greater than 10, and 4 minus 2x is less than 10. Oops, is less than negative 10, right? You got to do both. Subtract 4, we get negative 2x is greater than 6. I'm just going to solve this one straight down. Actually, let me do this one first. Minus 4, so we have negative 2x is less than negative 14. Okay, this is the part that I didn't talk about yet, and it's just an extra little step. When you're dividing by a negative sign, the rules of algebra say that we divide this side, as we normally would, but the inequality changes direction one more time, okay? Because you're dividing by a negative number, the rules of math say that you then have to change the direction of the inequality sign. 6 minus 2 is 4. So instead of getting x is greater, oops, I'm sorry, I didn't even switch that, I was talking about it. Instead of getting x is greater than 4, you're going to get x is less than 4. Over here, same thing. We're dividing by a negative number. So because we're dividing by a negative, we rewrite the x, the inequality changes direction. Negative 14 divided by negative 2 is positive 7. Okay, so it is one extra step, okay? We went through all these guys, no problem, but I did want to show you that one last step because it does show up in some problems. Sometimes the teachers don't explain it, sometimes they do, sometimes it's not really mentioned in the problems, but I wanted to make sure that you are exposed to that as well, just so that you have that extra tool in your tool belt. All right, so hopefully that clears up all of these absolute value inequalities and how to graph them. I do have some other videos that I'm doing which are absolute value equations and stuff like that. So check out my other videos. Thank you so much for watching. Post comments, ask questions. If you're not sure what I'm doing, I would love to be that support person to really make this stuff come together. Okay, thanks again. Have a good day.